Hello, today we will talk about kinematics. Kinematics is the physics of motion. So let's get started. How we will learn the topic is first we'll go over the concepts and then we'll get down into examples in order to understand these concepts. This whole lecture is divided in three segments. The first segment we will talk about velocity and acceleration. In the second segment, we will discuss about uniform accelerated motion, and that includes gravity and free fall. The third thing that we will cover is projectiles. So, what is velocity? Velocity is displacement by time. It can be understood as the rate of change of displacement. Just note I use the word displacement, not distance. This can also be represented as dx by dt. If you're not aware of calculus, it's fine. Just understand dx by dt is a differential of x over time, and it represents a tangent in the curve. So for example, let's say the x-axis represents t, time, and the y-axis is the displacement, and the object is moving in such a manner, in such a path. At any given point in time, the velocity would be the tangent at that point. For example, at this point, this would be this tangent. At this point, it will be this tangent. Similarly, acceleration is again rate of change of velocity. In order to understand this in a graph in a similar fashion, if we change the displacement by velocity, the acceleration at, let's say, this point is the tangent. Similarly, acceleration at this point is this tangent. Acceleration at this point is this tangent. I'm guessing you all are aware of these five equations. Before we get into these equations, one thing is important to know is these five equations are applicable only when the acceleration is constant. So when the acceleration is constant, you can apply these equations. Otherwise, you cannot. Just note these equations have, every equation has one missing variable, and you can, when you have to answer these questions, you can plug the right equation based on what is missing and you can answer them. I'm not getting into the details about how these equations are derived. We will learn to use these equations in order to solve problems. Remember the five equations we talked about, and we said the acceleration has to be constant. So what is a good example where we have acceleration is constant? The best example that we have is gravity. So let me give you an example here, and I'll bring in the famous apple. So when the apple falls on the ground, the acceleration with which the apple falls is g, that is gravity. The gravity pulls the apple falls with the acceleration of g. Similarly, if somebody throws a stone up, the stone is also moving against the gravity, so the acceleration that is acted upon the stone is g, but because it's moving against the gravity is minus g, and in this, when the apple falls, is positive g. This is a very, very important concept, and because the g is constant in these cases, a lot of the equations that we have learned before are applicable in cases where it's free fall or where the motion is under the influence of gravity. Another thing I wanted to talk about in this lecture was when a stone or any object is thrown up. Let's say it has an initial velocity of v naught. The moment it reaches the top position, the horizontal velocity is no longer there. The velocity at this point, at the highest point, is 0. This is something that you should be aware of when you do any problems, because this is a very important concept and you will use it very often. Now let's get into a problem to us to understand these concepts. Most of the problems that we discuss here are from Princeton Review, AP Physics 1. But if you do not have the book with you, that's fine. I'll explain what the problem is, what the problem statement is, and then we can go about solving them. So the first problem that we have is a person throws a ball up with a velocity of 10 meters per second. The question is, how up will it go before it starts falling? So what's the maximum height will that attain? So in order to solve this equation, so what we need to find is the variable x. We know that the initial velocity is 10 meters per second. We also know when it reaches the top, the velocity becomes 0. So first we will find how long will it take to go up, and then we will find the distance. We know that gravity that is acted upon, since it's moving up, is minus g. And let's take, for our convenience, g to be 10 meters per second squared. That will make our calculations much easier. So in order to solve this, the first equation that we use is v is equal to v naught plus at. We know the initial speed, the final speed is 0. The initial speed is 10 meters per second. Since it's moving up, it's minus 10 meters per second squared times t. Yeah, so it's very easy. So t has to be 1 second. So it takes 1 second for the object to reach from here to the top post level. Now, in order to find the distance, next what we will do is we will use the other equation. X is half v naught plus v times t. So that would be half. The initial speed is 10 meters per second, final is 0, and we know it took 1 second, so that is 5 meters. So this distance is 5 meters. So the next thing that we will talk about is projectile. So let's say a soccer ball is being kicked at a velocity of v naught at an angle of theta. So what this means is, whenever you have a situation like this, you know from your experience that the ball will take this trajectory. This is nothing but a parabolic trajectory. So whenever you get a problem on projectile, always break the equations in one is in the horizontal direction and another in the vertical direction, and apply the same concepts that we have learned. So let me explain it to you. So it's v naught at an angle of theta. So when we break this in two different directions, so the horizontal velocity is v naught cos theta. The vertical velocity is v naught sin theta. Note, when the object is vertical, it is subjected to gravity. So if it's moving up, it's minus g. If it's falling down, it's positive g. In the horizontal direction, there is no gravity involved. So the object moves without any acceleration. There's no acceleration available. Another key concept in projectile is, when the object reaches at the top, the velocity at the top, the horizontal velocity remains v naught cos theta. the vertical velocity, this is 0. Also, another thing is the time it takes to reach from this point to this point is the same as the time it takes to reach the object to reach from this point to the till it hits the ground. So if this is takes t, the total time it takes is 2t. With these concepts, you should be able to answer any questions on projectile. So let's get an example on a problem and we'll see how to use these to solve them. So the problem states that a soccer ball is kicked at 10 meters per second initial speed at an angle of 30 degrees. How long will it be in the flight? So how long will it take to reach the ground? So as discussed earlier, so we break the speed, the vertical and horizontal. The horizontal speed is 10 cos 30, that becomes 5 root 3. This becomes 10 sine 30, that becomes 5 times half. 10 times half is 5. Okay. We know the velocity here, the horizontal velocity is 0. So if we know how long it takes the ball from 5 meters per second to reach the top, we know our answer. So in order to do that, let's use the equation v is v naught plus at. We know the final velocity at the top here on the horizontal direction, on the vertical direction is 0. Initial speed is 5 meters per second. Because it's moving up, it's acting against gravity, so minus 10 meters per second times t. So t is half a second. So it takes half a second for the ball to reach from here to this point. It will take another half a second to reach from this to this. So the total time in which the ball is in the air is 1 second. Okay, so this problem is a person is standing on top of a bridge. The bridge is 80 meters high and a stone is thrown at a horizontal direction. So the question is, what's this length? At what length will it hit the water? So in order to solve this problem, we will use the equation x is x naught plus v naught t plus half at square. Okay, so we know the vertical speed is 0 and the horizontal speed is 30 meters per second. We know this is 80. Okay, so since we are talking about the vertical side, so we will use x as 80. There's no x naught is 0 because we're starting from the 0. The vertical speed is 0, so anything times 0 is 0. Since the object is falling, it is subjected to positive gravity, so it is half g is 10 meters per second square times t square. So t becomes 160 by 10 t square, so t is root of 16, that is 4 seconds. Now the question is, it takes 4 seconds for the stone to hit the water, and since the vertical speed is 30 meters per second, so this distance would be 30 meters per second times 4 seconds is 120 meters. So this distance is 120 meters. So with this we conclude our topic on projectile and also conclude our chapter on kinematics. In case you have any questions, please feel free to put them in the comment section. If you would want me to change the way I'm delivering the class or the lecture, please feel free to give your comments. With that, happy learning and all the best.